Hello guys, trust you're doing fantastic. Now in today's video we're going to be treating more examples on the 2's complement form. Now let's take this example. It says, what is the 2's complement representation of minus 17? Now let's go straight to the solution. Now remember the syntax. You have the signed bit and the 2's complement actual binary. Now don't forget the direct method using this code. Now since the value is 17, what is the minimum number of bits required to represent 17? It means in this case we're going to have the highest number to be 2 raised to the power 4, because 2 raised to the power 4 is going to give us 16, right? So it has to be less than this value, 17. So 2 raised to the power 4 is going to give us 16. In that case, the minimum number of bits required to represent 17 is going to be 5 bits. So in that case, we'll have 2 raised to the power 3, 8, 2 raised to the power 2, 4, 2 raised to the power 1, 2, and 2 raised to the power 0 is 1. So it means in this case, for we to represent 17, it means 16 is going to be on, and 1 is going to be on, and then the values in between is going to be 0. So in that case, when you sum up 16 and 1, it's going to give us 17. So this is how easy. Now you may be wondering, how can I know the minimum number of bits required to represent a decimal value in binary number system? All you need to do is to ensure that the power the value raised to the power of n raised to the power x should not be greater than the decimal value that has been given to you. It should be less. So in that case, you can tell how many numbers of bits, the minimum number of bits required to represent that decimal value. Now, for example, if you have to take a little shift and say 2 raised to the power 5. Now, 2 raised to the power 5 is greater than 17. So therefore, it cannot be considered. It means we have to go a little bit. We have to take the next bit below, which is 2 raised to the power 4. So 2 raised to the power 4 is 16, which is less than 17. So whatever you have as raised to the power should be less than the value in decimal value. So this is how it is. Right, this is pretty straightforward. Now if you want to understand this more, in my subsequent videos, in my previous video rather, you can find most of this explanation. Alright, so it's practically the same like I just explained, but you can have some examples in the previous videos. Now let's get the actual binary of 17. The actual binary of 17 is going to be 1001. Like I said, 16 is present, that's why you have 1. Then 842 is absent, you have 000, and then you have 1 present. If you sum them up together, you're going to get 17. Now the sign bit for minus is going to be 1, because what we have in the question is minus 17. So it's going to be 1. The sign bit for minus is going to be 1. Now the first complement of 17 is going to be the inverse of the actual binary, which is known as the magnitude bit. So taking the inverse of this, you're going to get 0, 1, 1, 1, 0. So it's going to be inverse of 1, 0, inverse of 0 is 1, inverse of 0 is 1, inverse of 0 is 1, and the inverse of 1 is 0. This is nothing but the complement form. Now we need to put that together. So the 1's complement of minus 17 is nothing but 1, 0, 1, 1, 1, 0. Now this one is coming from the sign bit. That's why you have 1, and then you have this, which is 0, 1, 1, 1, 0. Now the question, from the question, it says we should derive the 2's complement of minus 17. So the 2's complement of minus 17 is going to be 1's complement of minus 17 plus 1. That's why you have this. So this is 1's complement of minus 17 plus 1 plus 1. So let's do this simple math. So 0 plus 1 in binary is going to be 1, and then every other value you have them the same. 1, bring it down, 1, bring it down, 1, bring it down, you have 0, bring it down, you have 1, bring it down. So hence the 2's complement of minus 17 is going to be 1, 0, 1, 1, 1, 1. This is how easy and straightforward it is. So alright then, enjoy this video. Bye.